I'm going to talk about the standard enthalpy of formation. The symbol for the standard enthalpy of formation is delta H for the enthalpy, lowercase f for formation, and this degree sign, which stands for standard temperature and pressure. In this case, that is 298 Kelvin, or 25 degrees Celsius, and 1 bar of pressure. In some textbooks, the symbol for the standard enthalpy of formation will be written slightly differently as delta, lowercase f, h, and then the degree sign. The definition states that the standard enthalpy of formation is the change in enthalpy that accompanies the formation of 1 mole of a compound from its elements with all the substances in their standard states. What does that mean? Well, let's look at an example. And we will be looking at the standard enthalpy of formation for liquid water. I'm going to write this reaction equation a little bit differently, with the product on the left-hand side and the reactants on the right-hand side. So in the definition it says that the compound has to be made from its elements. What are the elements of water? There is hydrogen, and then there is oxygen. It also says that the substances have to be in their standard states. So what are standard states? Well, a standard state is the most stable form at 1 bar pressure at 25 degrees Celsius. So at that temperature and pressure, hydrogen is the most stable as hydrogen gas. Oxygen is the most stable as oxygen gas. It also says that we are looking at formation of 1 mole of a compound. So we need to balance this reaction equation to get 1 mole of our product, water in this case. So on the product side, we have 2 hydrogens. On the reactant side, we have 2 hydrogens. So that is fine. On the product side, we have 1 oxygen. On the reactant side, we have 2 oxygens. So I need to multiply this by a half. And I'm going to rewrite this reaction equation. So now we have hydrogen gas, or 1 mole of hydrogen gas, plus half a mole of oxygen gas will give 1 mole of water in its liquid state. And as it so happens, the standard enthalpy of formation for water in its liquid state is negative 284 kilojoules per mole. How do I know this? Well, I looked it up in a table of thermodynamic values, which you can find at the back of any chemistry textbook. What does this value mean? Well, firstly, let's look at the sign. It's negative. Recall that when the change in enthalpy is negative, it means that the process or the reaction is exothermic. So energy is released or lost by the system. Next, let's look at the units. Kilojoules per mole. So it means that for every mole of water that is formed, the system loses 284 kilojoules of energy. So let's look at another example. This time nitrogen dioxide. So it needs to be formed from its elements, so that is nitrogen plus oxygen, and the elements need to be in their stable forms. So that means nitrogen gas and oxygen gas, because these are the stable forms at 1 bar pressure and 25 degrees of Celsius. We also need to balance the equation. So we have 1 nitrogen on the product side, 2 nitrogens on the reactant side. So I need to multiply this by a half. I have 2 oxygens on the product side and 2 oxygens on the reactant side, so that is fine. And I can now rewrite this as 1/2 of a mole of nitrogen gas plus 1 mole of oxygen gas will give 1 mole of nitrogen dioxide gas. The enthalpy of formation for nitrogen dioxide gas is positive 34 kilojoules per mole. Per mole. Seeing how the change in enthalpy is positive, it means that this is an endothermic process. Or in other words, we can say that for every mole of nitrogen dioxide that is formed, the system requires or needs to gain 34 kilojoules of energy. There is one more thing that I would like to cover in this video, and that is that the standard enthalpy of formation of the most stable form of any element is 0. What does that mean? Well, that means if we were to look at the standard enthalpy of formation of, say, oxygen in its most stable form at 25 degrees and 1 bar of pressure, which is oxygen gas, the enthalpy of formation is 0 by definition. The same holds true if we were to look at the standard enthalpy of formation for hydrogen gas. So that is hydrogen in its most stable form at 25 degrees Celsius and 1 bar of pressure. That too would also be 0 kilojoules. And we could say the same thing for nitrogen gas, because nitrogen gas, N2, is the most stable form of nitrogen at 25 degrees Celsius and 1 bar of pressure. So its standard enthalpy of formation would be 0 kilojoules per mole as well. So once again, the standard enthalpy of formation of any element in its most stable form will be 0.